Thank you, Melissa. I appreciate that. And thank you, everyone, for joining our webinar this afternoon. So as she said, my name is Brian Sather. I'm here with Jim Byrne. We're part of our design and manufacturing group at Autodesk. And what we really want to talk about today is what BIM means for manufacturers, specifically manufacturers of products that go into buildings, and how creating BIM objects is going to help us get our products spec'd in and get our customers to use more of our products in their projects. So the first thing I want to start with, Jim, go ahead, is level set on what is BIM, right? If you create building products, I'm sure you're intimately familiar with this, but I want to make sure we all start off on the same page. So building information modeling is basically an approach or a methodology that a lot of architecture, engineering, and construction professionals are using now to plan, design, construct, and manage their buildings. And what it boils down to, like I said, is a methodology, but at the same time, there's this ecosystem of software tools and collaboration tools that we need to be aware of in manufacturing to help them use more of our products in their projects. And the reason this is important is if you look at the current state of BIM adoption, you can see the growth that's happened even over the past couple of years. And so certainly in the past 10 years, you can see there's this significant amount of people now using BIM in their building projects. And even in the past 2 years, it's gone from 54% to 74%. And this is coming from a study done by NBS. It's their 2018 National BIM Report. And it's a really interesting report. If you haven't taken a look at it, I encourage you to go and download it and take a look at some of the stats in here. But this one is getting to a point now where the vast majority of new building projects that are being undertaken are now using BIM as the underlying methodology. And the reason this is important to manufacturers is there's a need now for BIM objects. And in the same survey, 75% of the respondents said we need manufacturers to provide us with BIM objects. And this is really critical from our standpoint, because as more and more of these projects are kicked off using BIM, we need to be able to provide our products in a format that's compatible with the software and the tools that they're using. And so on the next slide, we talk about what are BIM objects. And this is really the meat of it right here. When a customer comes to us and asks in a quote or in a bid process, that we need a BIM object as part of that, we need to understand fundamentally what that means and what it is. And it comes down to three basic things. The first thing, obviously, it's some form of geometric representation of the model, right? As is most things that we deal with. The second thing is actually a bit more important, is it has the appropriate metadata attached to it. And so you can see off to the right that there's a description of what this item is. And this is an office chair. So it's a pretty simple object. It also has some dimensional attributes, right? An overall envelope of the width and depth and height. It may have weight attached to it, materials. And then as you get further in the design process, the level of detail and the amount of metadata attached to these BIM objects increases. And so we're in the construction phase here, as denoted at the top. We're actually specifying who the manufacturer of this particular chair is, what model number it is. Now, for building products or building equipment that have attachment points to the building, but be it electrical or plumbing or some other form of attachment, you can specify that as metadata as well. Now, the third thing is that these are discrete products. And so it's not a system or a layout, it's some object that we're placing in. And the way I usually like to describe it, if you're coming from the CAD side of things, mechanical CAD side of things, is it's almost like our content centers, right? We want to pick something out of our content center that we're going to buy off the shelf, place it into our design, and work from that. And so a lot of time, in thinking about BIM objects, it works in much the same way. It's just the variety is going to be a little bit more diverse. Now, in the manufacturing world, we deal with CAD models. And it's important to know the difference between the CAD model and the BIM object. So CAD, the way that CAD systems have evolved over time is they're 100% focused on making whatever it is that you're designing, right? We're thinking about the manufacturing side of it. So it's going to have highly detailed geometry, and every component that's needed to create that final assembly is going to somehow be modeled and inserted into that CAD file. They're also manufacturing centric, right? So we create drawings from these for the individual components. We create assembly instructions, and any metadata that is attached to the CAD model usually is manufacturing oriented. With a BIM object, it's got an entirely different purpose, right? The point of the BIM object is to know what we're installing, how to install it, and then ultimately how do we maintain it down the line. And so for that, we need less detail in the geometry. BIM objects usually have relatively low amounts of detail. And then, as we mentioned before, all of the metadata that's needed to understand what kind of component it is so that it can be cataloged properly. How am I going to install it, both physically in the building, but also to any other systems that it needs to be attached to. And then also information about maintenance and things ongoing in the building. So we may attach like a replacement cost or a maintenance interval or things like that. And a lot of the information that usually goes into your spec sheet would ultimately be, it can ultimately be attached in the metadata of your BIM object. The good news is creating these from our CAD models really isn't all that difficult. It boils down to basically 3 steps. The first thing we need to do is simplify the amount of detail that we have in that model. So we need to take that high fidelity, manufacturing oriented version of the model and convert it into a lightweight representation that's more appropriate for the BIM software that our customers use. The second thing we need to do is add that metadata in, right? And this is, as I've been talking about, it could be a variety of different things, but we need to make sure that the information that's usually in our spec sheet gets attached to the file in the form of metadata. And then the last step is exporting them out as BIM objects. And we want to make sure we're exporting them in a format that is compatible with the software that they're using. So the first step is model simplification. And here we've got 2 different versions of the same model. On the top is our original CAD model, and below is the simplified representation. So you can see the amount of complexity that often goes into what we ultimately build, right? In this example, we've got more than 500 components in this model. A lot of the small detailed features are still there. A lot of the holes and fillets and smaller detailed geometries are included. And if we were just to export this model out as a step file and send that to our customer, it'd be over 20 megabytes, which in our world is really not that big. But to insert a 20 megabyte file into a BIM project is all of a sudden, that's big. That's going to start slowing down their system, especially if they're going to add multiple BIM objects of this size into their building. The simplified representation down below, and we removed the sheet metal from the back, so this does ultimately be enclosed, but I wanted to show the inside so we could share a little bit about that. It has a 90% reduction in the component. So we've stripped out everything that's really not needed to insert this into the building model. All of the detail features are removed. So you can see all like the little small holes in the sheet metal, all that's been stripped out. The one thing that we've paid close attention to is to make sure that our connection points are preserved, however. So there's a couple pipes coming out the top of this thing that we're going to have to connect to when this gets installed into the building. And so we want to make sure we preserve those things so that when it comes time to route our pipes to this object, we know where they got to go. And then, as we'll talk about in the next slide, there's some additional metadata attached to it. And when we export this thing out, it's 650 kilobytes when we do it as a Revit family. And so we've gone from, originally this was a 90 megabyte project natively when done in Inventor, to a 20 megabyte step file when we export it out, down to 650 kilobytes, which is right in the sweet spot for where we want to be when we create a BIM object. For the authoring of the metadata, we do this on a few different fronts. The thing you see, the item you see on the left-hand side is a pipe connection to a chiller. And this is where we can define any connections that we have to the product that are going to have to be accounted for as we're speccing out the rest of the building design. And so in this case, it's going to be a domestic cold water pipe. We can attach additional metadata to this connection. So we can specify that it's going to be a 5-inch diameter pipe, that the flow direction is coming out on the top pipe, what the connection type is going to be. And we can even get in there, if we had the values, we don't have them in this case, and specify what's the flow rate required for this particular connection. And so the engineer that's ultimately working on these hookups has all of that information at their fingertips as they're designing the plumbing going into this. You can do this for more than just pipes. You can do it, like I said, for the electrical. You can specify the voltage, phase, all that type of information. Same thing for ducts or conduit. You can specify all that information and attach additional metadata to any connections you have coming in. The second piece of it is authoring more general data, metadata about the product. And so the first item is we want to make sure that when this gets placed into the building model, that it is logical in how it does that. So if we were to put our, you can see the kind of triad in the middle there. If that were to be maybe at the center of gravity or the center of mass of this object, when they placed it on the top of their building, it would look a little weird. We'd have to move it back up. So we can specify the insertion point. We can also specify the omni-class classification for the product. And this is really important because as architects or contractors begin importing these BIM objects into their project, they go into something like a content center and they're sorted based on this omni-class classification system. And so by specifying that, they can import it in, and when they're ready to place it into their model, they can easily find it within their content center. We can also start specifying additional metadata. And so here you can see we've got the description, the manufacturer, the model number, a URL to the website. And we can go a step beyond this as well and start attaching properties from the model itself. So we talked earlier about the overall dimensions, height, width, depth. We can specify the weight, and it's calculated based on the model itself, the original model that we did before we simplified it. And we can add in other factors as well, such as cost data and things like that your customers are ultimately going to want and need as metadata in their BIM object. Now, the great thing about this is there are some standards organizations out there, NBS being one of them. And you can go to their websites and you can refer to, for each category or each type, I think it's based on omni-class or based on a category, you can see the types of metadata that are relevant and required for the types of products that you make. And so all of this, there's references and information to help you figure out what types of metadata to include as you're authoring this out. Now, the last piece of it is actually the easiest part, and you've done the hard work already of simplifying the model, adding the metadata. Now you just need to convert it to a format that's compatible with commonly used BIM software. And so Jim's going to show this in a little while when we get into the demonstration part of it. But one of the options is to export out to a Revit family. Revit's a very commonly used BIM application. And so being able to export out to a Revit family natively is a convenient way for them just to get it into their library and have it import into Revit very nicely. Two other options, the IFC format is a neutral file format that's been widely adopted within the AEC industry. And then there's the Autodesk Exchange, which helps to exchange some of these objects between different applications. So that really covers those big three. We're going to throw a little curveball in here now. So the three steps are, like I said, are relatively simple if you have kind of one-off products or you have a few configurations of your product and set model numbers and things like that. But what happens if your products are configurable, right? What if you allow your customers or your customers come to you and say, I need a custom version of what you sell? This vent hood is a perfect example of something that, depending on how it's configured, you could result in potentially hundreds of different variants. And the last thing you want to do is go through each one of those models and create each one of them individually, export each one of them individually based on all the different possibilities, considering that they got a free form field here for the width, for example. You can do different ceiling heights. different finishes on this. So how do we accomplish this aspect of it without necessarily having to go through, those 3-step processes for every potential combination? And so the first step in doing that is to use something we call rules-based design or design automation. And what this allows you to do, I'm going to wait for the slide to transition here real quick, is to define rules. And there's an environment within Inventor, and Jim's going to talk about this here in a little while. There's an environment in Inventor that allows you to define rules that ultimately drive parameters. And so each rule can drive more than one parameter at a time. And in this case, for this faucet, you can actually see the different use cases and what actually happens. So if a user selects flush, you can see what the height, length, S length, cost, and weight are all going to be set to when the user sets that variable that way. And then there's another example for the bath, right, where all of a sudden our height goes up a little bit, our length goes up a little bit, cost goes up, and so on. Now, on top of these rules, you can create forms that basically act as triggers so that there's a nice user experience to configure your product. And these parameters, they can include any of the dimensions that you've named as parameters. They can suppress components or include components. So back to that vent hood example, there were some edge bands that were used as trim and rivets. Those can be turned on or off depending on whether the customer actually wants those. You can change the materials. So again, on that example, you could go from stainless steel to hammered copper or other materials. You can do cost manually, like on this faucet, or you can do cost calculation. You can change the appearance, and you can do a whole lot more. Basically, any property or any parameter that's in your Inventor model can be driven using this environment. And it's a great way to quickly configure products based on the common ways that your customer would ultimately want to do that. So doing this inside Inventor is great. It means that your engineering team or your sales engineers can pull these models up in Inventor. They can bring up these forms. They can configure the product. And then the simplification and the metadata can still happen automatically. So the simplification is kind of, a master model of simplification. And then the metadata can be populated using the logic in these forms, or it can be automatically calculated based on how the design has changed. And so there's a lot of power here, like I said, that can be given right to your engineers or your sales engineers. And then there's one additional thing we can do. Jim, if you want to bring up the next one. If you've defined all these rules in Inventor, you can then deploy that to an online configurator. And this is an example of a customer conform, where if you actually go to their website today and you go to their build a quote application within their website, you'll see how they've used this capability to allow customers to configure. These are roof mounted platforms. And so they can go in there and they can allow their customers to configure their model at will based on the rules that they defined inside of Inventor. And then they can export out in a variety of different formats. They can export out to CAD format, they can export out images, but most importantly, they can actually export out that Revit family. And they can pull that along with all of the metadata that's been attached to it, and then include that into their building project. And so from a workflow perspective, this looks a lot similar to the other workflow. We just added a couple interesting bits in here. So first, we have to do that step of defining the rules for the configuration. Then we still do the simplification for the level of detail. We still add all the metadata. And then we upload it to that online configurator, where now our sales teams or our customers can go directly to configure and export that model out as, like I said, a Revit family. And so all of that sounds good. I think I've talked enough. I'm going to pass it now over to Jim to actually run through how some of this stuff actually works using Inventor and using one of our online configurators. So go ahead, Jim.
Okay, great. Give me just a second to minimize your slide deck. Okay, so Thank you, Brian. Hi, everyone. Once again, my name is Jim Byrne, and I'm going to take a lot of what Brian had just gone through in his deck, some of the examples that you had seen on his slides, and I'm looking forward to walking you through a demonstration of creating BIM content. And what you're seeing here is live. We sometimes use videos to demonstrate the software in webinars, and it's always more fun when you get to walk through a demonstration this way. I've got two examples that I want to show that again we went through in the slide deck for building equipment manufacturers who are looking to create BIM content. It's the Mammoth chiller that you see here, and we'll use this piece of HVAC equipment. A little bit later, we'll go through another example of the for building product manufacturers. This mixer I'll show an example of how to use this as well using iLogic that Brian just got done talking about. Well, let's get started with this this Mammoth chiller. One of the things that I think a lot of designers will probably find is when you're done creating something like this, if I were the designer of this chiller, I might say, wow, this is just beautiful. I love this design. Who wouldn't want this design? It has everything that they want, but in reality, as Brian was saying earlier, this assembly is much too detailed to use inside of a building project inside of Revit. So we do need to simplify it. And what I want to do is walk you through a couple of different ways of doing this. So this is the first method, and then when we get to this other piece of HVAC equipment, we're going to talk about the second one. Well, with the Mammoth chiller, let's bring this up here a second. I want to walk you through starting with Simplify View. And basically what this does is it will generate a new view for you, but it's got a nice interface for it. In fact, once this pulls up, let's open up our view tab here. We've got a couple of views in here right now. And when we use this tool, we are basically telling the software what we want to keep. And we have different selection priorities. First, I want to pick on the cabinet, which is this overall subassembly. And then we can also change to some smaller components like this 30-inch fan tube that we have up here. I not only want to, if I have a lot of these in here, then we can also select all instances, which will save you a bunch of time on some of these components. And then we want to do the same thing for the inlet and outlet over here on the side. But once we're finished, we can accept this, but then there's a couple of nice options to view what we have so far, like a preview, or even view the parts that we're eventually going to end up hiding or not use inside of the simplified component. So we'll go ahead and just accept this. This is what I want. And like I said, it's going to create a new view for us. And this is a nice simplified view. It still has a lot of detail in it, not just the components at a component level, but it has a lot of features that we might not want to use too. So again, in the next design, I'm going to show you Shrinkwrap, but there's another way of simplifying this way down to some primitive objects. So define envelopes will help us to do this. And once again, we can change our priority, which is real nice for selection. We'll start with this cabinet. We have the ability to define an envelope as a rectangular box or a cylinder. And we can stay in the command here. We'll just go ahead and apply this. And so we get a nice simplified object there. We can do the same thing for the fan tubes at the top. And once again, we do want all of them. Now you can see a preview there too. It shows us what a rectangular object might look like for an envelope. We'll change that to cylinder and apply that to all instances. And then the same over here too for the inlet and outlet. Okay, so we get a highly simplified object that we can use as our BIM object. Like I said, I'll show you another way of doing this too, where we can retain some of the detail if you'd like. But now, before we create our BIM object or author our BIM object, we'll want to create a simplified part out of this that refers back to the original assembly. Let's give this a name. And we also have style up here for whether you want this to be a single body or if you want it to be these objects to be separate bodies. Those are some options that you have. Now, once this is saved, this part that you see here, a couple of things. You can see it does have features over here. It recognizes those features, these envelopes, as features that can be edited, but it will relate back, or it maintains an associative link back to the assembly. So if we decide we want to make any changes to that, it will update in this part document as well. So now we have a nice simplified design that we want to use as our BIM object. We can enter the BIM Content Ribbon. And so now that we've removed all this detail for the geometry, we can go ahead and add some information back in. Starting with MEP connectors, we've got cable trays, conduit, ductwork, piping, electrical. We can add these to this inventor model, and then they will show up inside of Revit when we bring it in. A couple of things we can do in here. Let's zoom into our inlet and outlet. I've got a pipe connector. It will actually provide a size for you, and it is customizable, and specify the system type, which will give us some options that we can use in here. I'll just make this real simple. This is an outlet, and we'll do the same thing down here. This is going to be supply. Okay, and then when it comes to authoring, Brian had mentioned this in the slide deck, but the UCS can sometimes be important depending on how you would set it up. A lot of times for a designer of, for example, this chiller might have in mind how they want their orientation of their model to be for a front, top, and right side view for possibly a drawing. But for the architectural industry, the Z-axis may point in a different direction. So we can add our own UCS. And I think you can do that here too inside of authoring building components. But in here, we're going to, again, do what Brian had mentioned earlier. We can specify our Omni class. And other additional information that we want to apply, such as description. This is our roof mounted HVAC unit. And we have our manufacturer. We could put in the model number and possibly some information for the building contractor to find your website if they're going to use your design. And then we can go ahead and export it as, let's go ahead and save this off. Export it as the file type that we want to use based on where we're going to use it. So in this case, we can export it as a Revit family file or an industry standard IFC file. We'll go ahead and stick with Revit family file. And once it's finished, we can take a look at what it looks like inside of Revit too, just to, in case for some of you on the call may or may not be users of Revit. I am not a regular user of the software, so don't laugh or yell if I make a mistake. Actually, this is a webinar, so you're all muted. You can laugh and yell as much as you'd like. Oh, actually, it's under here. So there we have our chiller. And let's put this on a different level. We'll drop it over here somewhere. And when we select our Revit family file, our chiller, then you can see the 2 connection points that we had added for pipe. And as you'd expect, you can go ahead and draw your pipe from there. I won't go into too much detail here, but or maybe you've got other parts that you want to add, like an elbow. We can go ahead and do that too. But you get the idea. Those connections are added to the Revit family file for use inside of Revit. Let's take a look at another example. Here we have another HVAC unit. Now, once again, with the Mammoth chiller, we use simplified view. We defined those envelopes, and we created a simplified part. Well, this time, let's take a look at Shrinkwrap. Shrinkwrap is going to give us quite a few more options. It might be overwhelming the first time you go to this dialog, but I think what I'm going to show you is very simple and easy to use. Basically, what we're going to do is we're going to address the components that we have in the design and the features as well, and then finally create the model. Under the Components tab, we want to start by removing some of the detailed parts that we don't need in the Revit model or in the BIM object. And we can do this via a value or a size. Let's say, for example, I type in 90. You're not going to see much happen in here. There's several components that are below 90 millimeters, and we can take a look at them in the View panel here. You can see that we have 379 parts that are shown and 160 that are hidden. And if we select those, you'll see there's a lot of little parts in here that we're about to remove. So if we bump this up to a lot more, say 900 millimeters, then of course we're going to see a lot more parts. And so this might be good enough for now, at least to give us a good start. And then we can go back to the View tab to see what's going to be included. And from the graphics view, we can select all these parts that are above 900 millimeters that we still want to remove. And so this is just a real quick way of doing this. All I'm doing is just picking what I want to hide. Simple as that. And this may be good enough for right now. But there may even be parts that were below 900 millimeters, like this piece that you can't see here anymore. No problem. See what's excluded. And again, pick those parts, and maybe there's one on the other side too, to show those. Or Brian had mentioned this too. We want some of these parts we want to keep as a reference for connections. So select those to make sure those are shown too. And then we can move on to features. So in the Features tab, we've got, if you look here closely, we've got a lot of holes all over the place. And in this dialog, we can either remove all the holes, and we can actually preview this if we want. And there's, like I said, I don't know how many holes there are, hundreds of holes. It's going to, in just a couple of seconds, preview all of them that are going to be hidden. Now, there might be cases where you want to keep a hole, like this one over here. Well, there's a couple of ways to do this. You can either manually select the features that you want to preserve, but if there's a lot of them, then we've got another option in here to say, you know what, let's hide everything that's below 20 millimeters. And we can preview that too. And in another example, I'll show preview or preserve features as well. But you can see then anything that's above 20 millimeters will be kept. And also on these sheet metal parts, I've got tons of bends, and these are basically fillets as far as geometry is concerned. So we can remove all fillets in this case too, and we'll see what that looks like in just a moment. I'm going to go ahead and create this simplified part, and we've got options for the default BOM structure, for the style that we mentioned earlier, except this one has one that you didn't see in the Mammoth chiller. We can save it off as a single solid body, multi-body, but also as a single surface. I think this looks good. Let's go ahead and accept that. And then once again, what we're going to get in just a matter of seconds is a single part document. In my case, it's multi-body. And it maintains that associative link back to this assembly for any changes. But not only do you have that associative link, when it's done, I'll zoom this out a little bit, you can see it's nice and simplified, but it kept those large holes for us. If we go to our browser over here, we can edit the Shrinkwrap assembly. So that brings us right back to the same dialog that we were just in to make any changes, just in case we missed something, or we can go back and edit that. So pretty awesome. And then I'm not going to go through this, but just like the Mammoth chiller, we would add our MAP connectors, author the building components, and export it as an RFA or IFC file. So let's move on to another example. This is the mixer, another one of the images that Brian had up in his slide deck. There's a couple of things I want to do here. One, with the Shrinkwrap tool, there's two things that I didn't show yet. Again, with components, we want to remove a lot of the smaller parts in here. Well, if you don't know what size to put in, then another thing you can do is pick on one of the parts, like this bolt that we have here, and it will use that as its size. So that might save you a little bit of time. And under the Features tab, in this case, we want to, let's say, remove all holes. We've got some holes down here in the bottom, got one up here in the top, and we can preview that because it's fast. Same goes for the fillets and chamfers. We got lots of those. You can see it does a really good job of eliminating those for us to create a simplified part. Yeah, but there are some holes that we might want to keep. So with preserve features, we've got these two holes that we might want to use for MEP connectors, or you might have holes in your design that are used for mounting locations for how your design is going to be mounted to a much larger design. And once again, we can preview that to see what it looks like. And if it looks good, then we move on to create our simplified part. Oh, here's another thing worth mentioning. When you create a simplified version of your design, what happens to the mass property information? Well, it gets smaller, right? Or usually it does. And so you will get a question that says, do you want to keep the mass properties of the master level of detail, which is your manufacturer design, or of the simplified version? So most of I don't know why you wouldn't select yes, but if you select yes, then all the mass property information will reflect the manufacturer's information, or the manufactured version. So let me go back to let's go back to this design again. There's another thing I want to show. This is a configurable design. We have a form that can be used. So, or let's put it this way. What happens if we put this in the hands of your customer? Your customer wants a particular version of the design. Well, what if we could give them the ability to configure the model that they want, and then they can export the RFA or IFC file from there, rather than you going through the work of creating the BIM object, exporting the RFA, and then sending it to the customer. So with this form, we can select, let's say, a couple of different options between basin and bath, or maybe we want a different finish or level of detail. So these are all things that your customer can define, and I'm going to show you how that's done. Well, actually, first of all, Brian had mentioned this earlier. How are these different configurations created? It's done through the rules and parameters that you have in the design. So, for example, if I access the parameters, we can do some of this from here too, outside of the form. You can see that as you choose these different configurations, different versions, it will override the dimensions that we have in the model. Okay. Oh, and another thing I should mention too is earlier, so we use Shrinkwrap, we use Simplified View, and in this case, since we're using a form to drive the different levels of detail that we have in the model, let's open this up. Basically what it's doing here is it's suppressing and unsuppressing the features that we've created in the design to show that that simplified representation of the model. So those are either suppressed or unsuppressed depending on the rules that we have in iLogic. Now, earlier we saved the assembly off as a part document that refers back to the original assembly, but this time we're going straight to the environment or straight to the BIM Content tab so that we can apply some of our for example, MEP connectors. We might want to add a pipe connector in here for, let's just say we want to use maybe a cold and hot water connections. So we've got a couple of inlets. And all of our authoring, all the metadata that we want to add is already in there, so we're good. Now, before we exported it off as an RFA file, but this time we're going to upload it to Configurator 360. Let's save that off. And we'll just leave this, we'll just call it Mixer. So here inside of Configurator 360, we're uploading our model, and this is the admin interface. But the customer is going to see something like this. Now, this can be either placed, this can either be used inside of the Configurator 360 interface, or it can be used on your, or embedded on your own website. And you saw the example that Brian had in his slide deck as well. But then the customer is going to have the ability to configure the product that they want. For example, let's go back to, we'll change the type to a basin. We may want a different level of detail. We'll go with medium to simplify the design. And then from here, we can go ahead and export that as a number of different file types. Now, there's a lot of them here, but this is fully customizable. You can decide which one of these you want available to your customer. And of course, in our case, we're looking for an RFA file or a Revit family file. Okay. And then once again, inside of Revit, we can see what that looks like. On level 2, I've got a sink in here. And of course, we have the ability to bring that right into our design. There's our mixer. We'll drop that right in. We can see it in a 3D mode too. And there you have it. And for good measure, let's render that off. So just as a recap, we demonstrated Simplified View, where we define envelopes and then we create a simplified part using the Mammoth chiller. It's a quick and easy method. That's one of the reasons why we like it. And then we used Shrinkwrap on the HVAC assembly. And remember that Shrinkwrap helps us through the process of removing the parts that we don't want based on size and selection from the graphics view. And then we can also remove detailed features like holes and fillets, pockets, chamfers. And then with this mixer, we demonstrated how your customers can select the configuration of your design that they want and export the Revit family file from your website. So I hope that this live demonstration was helpful to you. That's it for me. Brian, it's back to you. Here, I'll pull up your deck.
All right, and that just about wraps up our webinar. There's a couple last things. If you have any questions, now is a perfect time to ask them in the questions panel. We did have a few come in throughout the presentation that we'll go through answering for the group. And so feel free to use that questions panel in the webinar. And then if you can go one more slide, Jim, there's if you'd like to speak with one of our sales reps or one of our technical people, please use the chat panel and just let us know. And we'll have someone get a hold of you and they can talk through this process a little bit deeper and relevant to your products. So Melissa, do we have any questions?
I am looking now. Looks like we've got a couple that are coming in. First one reads, does it need to be native inventor to be able to simplify it?
In this case, no. We have a feature in Inventor that our marketing folks like to call AnyCAD. So you can bring in files from SolidWorks or Creo or many other CAD systems right into Inventor, and you can actually follow the same process using those files as you would a native Inventor model. And so you can do all of the shrink wrap and the simplification and then the metadata authoring from that file that you brought in.
Okay, and the following reads, can I remove my company's intellectual property?
Yeah, as part of the simplification process, that happens. So if there's something specific that you want removed, then obviously you have the opportunity to do that using the shrink wrap tools that Jim had talked about and shown.
Okay, our next one asks, will this be posted for later review? Got called into a meeting and had to miss a bit. Yes, it will be recorded and it will be sent to everybody that's on this call, and even those who had registered it but maybe couldn't attend or couldn't attend the whole presentation. And as Brian mentioned, go ahead and let us know via the chat panel if you do have, if you would like to have an Autodesk salesperson call you. If you have any questions at all, don't forget to reach out to Brian, Jim, or again, just make sure that you include it in the chat window here. All right, great. Well, thank you to all of our speakers. I think this brings us to the end of our Q&A session and presentation. Just a reminder, we will be sharing with everybody the on-demand recording. On behalf of Autodesk, we'd like to thank everyone for joining us today, and we look forward to seeing everyone next time.